Today we are looking at Glencoe Accelerated Math, Lesson 4-7 on the real number system. The real number system is divided up into two parts. So if we're looking at a hierarchy, we have the real number system, okay? And the real number system is divided into two parts. We have rational numbers and if we want to get a little bit more specific, we're on page 144. If we want 160. Hold on.
If it's the real number system, it's 174.
You're right. It's 174. I apologize. All right. I apologize.
Does that mean that?
I'll double check the numbers in a minute.
No.
I'll double check the page numbers in a minute. Ladies and gentlemen, if I wanted to get slightly more specific than a rational number, what type of number would I be looking at? No. What types of numbers do we have? Yes. Okay. And what do we call a number that's positive or negative but doesn't have a fraction or decimal with it?
Integer.
Okay, so those are integers. Alright, what if we get rid of those pesky negative signs? Then what type of number do we have?
Whole numbers.
Then we have whole numbers. And if we get rid of that silly zero, what type of number do we have?
A natural number.
A natural number. Okay. Now, if our numbers are not rational, what type of number would we have? What would be the opposite of rational?
Irrational.
Irrational. So, I'll wait. So, we've looked at natural numbers and whole numbers and integers and rational numbers before. Well, now we're going to add in the irrational. Okay? And an irrational number those are non-terminating, non-repeating decimals. So what that means is that we have numbers that are decimals that are never really going to end and they're never going to repeat. Can anybody think of an example of one of those? Yes.
One.
But does one end?
Yes.
Yeah. So then would that be a non-terminating, non-repeating decimal?
Yes.
No. Okay. What I need you to do, we're going to do things a little different here for just a second. Okay. I'm going to need you, when you finish writing this down, to come up around my little area here. Okay? So once you finish, you need to write down the hierarchy, then you need to come up and see. What? All right. So once you have this, you need to come up and see me. Huh? going to ask you to come here. You need to get the phone, take it out. Okay, you're going to come stand over my shoulder so that you can see what's in front of me.
Alright, so you want me to put the phone high?
Now I want you to turn it so that you can see the floor. Okay.
See my band folder anywhere?
You can check on top of the computer part. Alright. Again, once you have it, you need to come up so that you can see what we're doing. You can see the floor?
Yeah, I'm trying to get the kids.
Okay. Thank you. Alright.
Bring boom.
Shh. Okay. What I have, we have two sets of numbers, correct? Within our real number system. We have the rational on one side and we have irrational on the other. And then within the set of rational numbers, we can have integers and whole numbers and natural numbers. Alright? This is a kind of different Venn diagram. This Venn diagram is different because it says that all natural numbers are also whole numbers. Is that true?
Yes.
Yes. And are all whole numbers integers? Yes. And are all integers rational? Yes. And are all rational numbers real?
Yes.
Yes. Are irrational numbers real?
Yes.
Yes. Yes, they're still real. Okay.
Numbers can be fake?
They can be imaginary.
What?
That's something you'll get into much further down the road. Okay? So, what we have to be able to do is classify numbers based on the most specific category, or the most specific type of number that they can be in relation to our hierarchy. So if I had the number, let's start with those, 3/5. If I had 3/5, where would I put 3/5? What type of number is that?
Integer? No.
So it's a fraction.
It's a fraction. Where do I put fractions?
Rational.
Right, it's a rational number, so I'm going to put it
Oh.
out there. Alright? What if I had 2/3?
Rational.
That's rational too? Okay. What if I had -6?
Irrational. Integers.
Natural.
Integer.
Okay. -6 is going to be an integer.
Hush.
Alright. What about the negative square root of 25?
Irrational.
Why did you say irrational?
Because it's a square root.
Because it's a square root. Alright, well let me ask you this. Do we know what the square root of 25 is?
25.
Nope. 5. Okay, so the square root of 25 is 5, and then we need to make it negative, right? Okay, so what does this represent?
5 times 5.
What did you guys just tell me the square root of negative 25?
Negative 5.
Negative 5. Okay, where would negative 5 go?
Integer.
What about negative 10 over 2? Can it be simplified?
Yes.
Oh,
And a -5, so it's an integer.
So that's also an integer. Because 10 over 2 simplifies to be 5. It has a negative sign in front of it. What about 0.4 repeating?
Rational.
Rational. Because we can write that as a fraction, can't we? We don't like to, but we could. Alright. What about 0.5?
Rational.
A whole number.
Huh?
That is not a whole number.
That would be rational.
Good try.
It's like part of a number that's rational.
What about 0.349 that
Rational.
repeats?
Rational.
Rational. Again, can I write that into the form A over B?
Oh,
Yes.
Yeah. 2.25?
Irrational.
Natural.
You guys are just trying to get an irrational number, aren't you?
Yes.
Rational.
Okay. We do have some irrational numbers, but look, it's 2.25. For that to be irrational, it has to be non-terminating, non-repeating decimal. Is this going to be non-terminating, non-repeating?
No.
Yes. No.
No, because it terminates and it repeats. And it does not repeat. So because it terminates, that means it ends. It's already not going to be irrational. So what type of number is this?
It's
Hold on.
natural.
I don't know.
It's a rational number.
Is anything with the point or like part of a number rational? Because like they're all, you know.
No.
There's a lot of rational numbers. I get it.
Anything with a decimal or a fraction.
Kind of. Yes. All right. What about the square root of 13?
Rational.
That's gonna be.
Wait, no. Irrational.
Irrational. Good. Why would that be irrational?
But you can't.
Because we got a lot of rationals.
Because you have a lot of rationals. Not a good.
Non-terminating, non-repeating, and decimals.
Okay. Can we estimate the square root of 13?
Yeah.
Yeah. We can tell, which integer it's closest to. We could even find it to a decimal place or two, couldn't we? Can we get a specific number? Can we get one number that multiplies by itself to give us 13?
Yes. 6.5.
6.5 times 2 times itself would be 36.25.
Well, I thought you were talking about like.
So, that's not going to work. That is an irrational number. Okay. What about the square root of 25?
Didn't we already do that one?
No, we did the negative square root of 25.
It's an integer.
Okay.
No, it's whole number.
Is it just a whole number?
Whoa.
It's also a natural number.
It's also a natural number. What is the square root of 25?
5.
Okay. What about 9/3? What about 9 over 3?
Rational.
No, a natural number. Because it
Why?
can be simplified into 3.
Right, it can be simplified into 3.
Yeah.
What about 0?
It's
Whole number.
How is it a whole number?
Because it's
Because the difference between natural numbers and whole numbers is that whole numbers includes 0. What about 2?
Oh.
natural.
Natural.
You got to. It's
What about 5?
Natural.
Natural. And last but not least, what about pi?
Irrational.
Irrational.
1415
What's pi?
something.
Pi is
It's
pi is the relationship between the radius and the circumference of a circle. Pi is a non-terminating, non-repeating decimal. Okay.
But like, what's the number?
We'll be abbreviating pi to 3.14.
Yeah.
You
I think I broke my finger.
You can go out more decimal places, but you only need to know 2. All right, any questions about this?
No, ma'am.
Okay, yes? Why did they name it pi?
Because
That-
pie's a circle.
But then why don't we call it cake? Or cookie?
Because they want pie. They like pie.
I will. Shh, how about this? Shh. Why don't you look it up and tell me?
Because the circumference of a circle is 3.14.
Not right now. All right, ladies and gentlemen, I need everyone to go back to their seat. We're going to do one more thing today before we finish up. Thank you. What? All right. The only number that... There is a really good question here. That question was, is the only number that would be, we could call whole, 0? And that answer is going to be yes, because all of our other numbers that are whole numbers are also natural. The only difference between our natural numbers and our whole numbers, natural numbers does not include 0, whole numbers do. Okay? All right. The last do today, we need to be able to order rational numbers from least to greatest or from greatest to least. Okay, some of them will be rational, some will be irrational. But we need to be able to put them in order and figure out what is larger, what is smaller. If we can do that with multiple numbers on a number line, can we do that with 2 and just use our greater than or less than symbols? Yeah. So, what I would like for us to do, we're going to jump ahead in our examples to example 3. Okay, we're going to jump ahead to example 3 on page 175. And what I'm going to do, I'm going to draw a number line. Okay? I have the following values. I have 8 4/5, the square root of 64, 8.3 repeating, and the square root of 76. Is 8 4/5, is that rational or irrational? That's rational. What about the square root of 64? Rational. What about 8.3 repeating?
Irrational. Rational.
Rational. And the square root of 76 would be? Irrational. Okay? So, we need to either put all of these in terms of fractions or all of them in terms of decimals. Which would you like to do? I like decimals too. So the first number that we had was 8 4/5. What is 8 4/5 as a decimal? 8.8. So on my number line, how do we just know that off the top of our head? Well, here's how I know. I know that if I double my denominator, go from 5 to 10, I can double my numerator from 4 to 8. And okay, so 8.8 would be about here. That's going to be 8 3/4, right? Yes? No. Yes, ma'am. It's a very poorly written 9. Would you like for me to rewrite it?
Yes, please.
Yes. What is that?
It doesn't look like a noose.
Okay, that's a 9. It's been fixed. Okay? The next number is the square root of 64. What is the square root of 64?
8.
8. So that's going to go right here at my 8. Okay? We have 2 of our numbers plotted on this number line. Which is greater?
64.
Which is greater, the square root of 64 or 8 3/4?
8 3/4.
8 3/4 is greater. Okay?
3/4.
Right.
Oh, yeah.
That's going to be greater than the square root of 64, which simplifies to be 8.
Right.
Now we need 8.3 repeating. I just need to go a little bit further than 8.3, right? Okay. 0.1, 0.2, 0.3. We're going to put that about here. And 8.3 repeating, we'll put about here. Everybody good with that? Yeah? Okay. Did our least value or our greatest value change when we did that? No. Okay. Now our last one, the square root of 76. Is the square root of 76 going to be closer to an integer of 8 or an integer of 9?
Integer of 9.
An integer of 9. Why?
Because 9 times 8 is 72.
Okay. But remember, our perfect squares are a number by itself. So we would have 9 times 9 would be 81.
81. That's why it'd be 9, because 81 is closer to 72.
Then 64?
Yes.
Yes, she's right. Okay. So, can I paraphrase what you said?
Yes.
Okay. What we were told is that 9 squared would be 81, and the square root of 81 would be 9. We know that the square root of 64 would be 8. 76 is closer to 81 than it is close to 64. So we're looking at something between 8.5 and 9 to be our square root of 76. So what do you want to try? Because closer than that, we need to guess and check. Yes. Okay, so we said it's going to be closer to 9, which would mean that our decimal would be more than 8.5. Yes.
8.7.
Okay? 8.7 times 8.7. 7 times 7 is?
49.
49. 7 times 8 is?
56.
56 plus 4 is?
60.
Okay? 8 times 7 is?
56.
8 times 8 is?
64.
Plus 5 is?
69.
69. I add them together and I get 9, 6, 75.69. That is pretty darn close to 76, isn't it? Okay? That's on the low end. Should we try 8.8 just to make sure?
No.
Yes.
Ma'am.
Yes, we're going to.
Try all your numbers.
We're not doing all of them, but this is pretty darn close, so we're going to try 8.8 to make sure it's not closer there. 8 times 8 is?
64.
8 times 8 is?
64.
Plus 6 is?
70. Whoa.
Okay, is this row going to be the same as that?
Yes.
Yeah, there was 8s. 4, 4, 7, 7. Alright, which is closer? Which is closer to 76? 75.69 or 77.44?
75.
8.7.
Okay, so the 8.7 is going to be closer. And so there we're going to put the square root of 76. So, ladies and gentlemen, on my number line, I have plotted 4 numbers. 3 were rational, 1 was irrational. We were given numbers in a variety of different forms. If I asked you which was greater, this 8.3 repeating or the square root of 76, could you tell me?
Yes.
Yeah. You could tell me. Do you have to do it on a number line?
No, ma'am.
No, you don't have to, but could you?
Yes, ma'am.
Sure, absolutely. Okay. Does anyone have any questions?
No, ma'am.
Yes, sir.
What are rational, like, how do you do irrational and rational and integers?
So, our rational numbers are any value that can be written in the form a over b. So anything that can be written as a fraction. That's rational. Our integers are any non-decimal positive or negative number in 0. Our whole numbers are anything without a fraction, no decimal, no negative, but it can be 0. Our natural numbers, those are any non-fraction, non-decimal, non-negative, not 0 numbers. So think about these are kindergarten numbers. When you started to learn how to count, you just went from 1 up. Okay, and we didn't have halves and quarters and fractions and things like that.
Yeah.
We were just working on 1, 2, 3, 4, 5, up to 100, right?
Yes.
Okay, those are our natural numbers. When we add 0, we get to whole. When we add negatives, we get to integers. And when we add those decimals and fractions, we get to rational. Okay? All right, any other questions?